Hello, everyone, and welcome back to another edition of Index Office Hours. The day is the 13th of August, and this is Index Office Hours 170. Thank you, Juan, for posting the agenda in the chat there. If you would like to check out the agenda, go ahead and check it out there. This is the town square where ecosystem participants come together and discuss the most important and relevant topics for indexers. We see a few new faces, so hopefully that was a useful introduction there. This is a conversation, particularly in today's conversation, there's going to be a lot of participation. We have the lovely Derek who's going to give us a wonderful demo about his Postgres setup. So I'm sure there'll be a lot of back and forth, a lot of questions. So feel free to get involved in today's conversation. And you can do that via voice. Try unmuting a mic, and if you're having any challenges there, I can try to help you. And you also have the text box in the corner as well, which you can utilize. And as a reminder, this is a call that's going to be posted onto YouTube and recorded and posted onto YouTube. So if you are concerned about privacy, please bear that in mind. And with that, let's get into today's exciting agenda. So as always, we give a shout out to the latest GRT IQ episode. And today we have episode 181 with 𝗨𝘀𝗀𝗳𝗂𝗋 𝗟𝗓. Danny is an incredible individual, someone who I used to work with at Consensus and is now the co-founder of 𝗨𝘀𝗀𝗳𝗂𝗋 Labs. It's a Web3 studio, and they are focused on building a open, safe, and composable Web3. Many of you might know they are the folks behind the Ceramic Network, which some of you may even have used as well. Yeah, check out the podcast. He talks a bit about his journey in Web3 as always. He wrote a book, which I think is pretty cool. And he also talks a bit about how he thinks, what he thinks about the graph and how he's leveraging it in his projects, I should say, plural, with 𝗨𝘀𝗀𝗧 Labs and Ceramic. So do check out the episode there, which Juan has linked. Thank you. And with that, let's get into the regularly scheduled Repo Watch section.
Thank you, Abel, and hello, Jan. Okay, today on Repo Watch, as always, starting with execution layer client, we have had a new Get release. This is version 1.14.8, and this is a maintenance release only with some bug fixes. Then we have had a new release for Arbitrum Nitro. This is 3.11 beta 2. Which introduces support for fast confirmation, improves antitrust dash stability, and adds some metrics, tracing support, and resolves a bug related to block hash retrieval. And then moving on to consensus layer client, here we have had two new releases. So one for Teku, so 24.8.0. Which addresses a startup failure bug in 24.6.0 that was affecting machines with directly assigned public IP addresses. So if you're impacted by that, please update to this release. And then finally, Lighthouse has had a new release, which is 5.3.0. which is a medium priority release that includes performance optimization and some bug fixes. And this includes also breaking change, so database schema upgrade for faster beacon node startup and more reliable block proposals with a new V3 block production API. And that is all we have for this week. So over to you, Juan.
Thanks, Anna. Okay, so for Protocol Watch, we have a few things to cover today, unlike last week. Starting from forum governance, we have JP67, which is deprecate the L1 mainnet protocol. The new series that the council approved this JP, and it... Wait, how is it quite weird? Can you hear me okay?
Loud and clear.
Oh.
Yeah, I can hear you fine. I'm not sure. Maybe it's coming through weird on Pele's side.
Okay, well, I'm gonna continue and hope that the recording is gonna be okay. No worries. Okay, so 𝗨𝗂𝗂𝗂𝗂𝗂, which is deprecate the 𝗨1 mainnet protocol, the council approved it. So yeah, it went live. So the 𝗨1 infrastructure is off, and support for transfer tools is gonna be basically done by December 28th, as per the 𝗨𝗂. For firm research, we don't have any new updates. For the contracts repository, there are a few PRs that are mainly for Horizon, particularly the subgraph service. These are mostly PRs coming from the last round of audits, it seems, because they are all from Open Zeppelin audit codes. Network subgraphs don't have any new updates since last IOH, and that's pretty much it. Yeah. So I don't know if Paka is here. If not, I'm gonna. Yeah.
Yeah, he's not. So we'll go straight into open discussion. Amazing. Thank you, Juan, and thank you, Anna, for your respective sections. So now we go into the open discussion, of which I'm very excited. We've got Derek, who's going to be telling us all about his Postgres setup. We had a very interesting conversation last week, and there's a lot of follow-up. And one of the requests was this particular session. So Derek, without further ado, the mic is yours.
Booyah. Okay, cool. Let me share my screen. So as just kind of like a quick highlight, or I should say quick backstory. So prior to being in the Graph, I worked as a database administrator. It was all inside of the Microsoft SQL stack. So all of my normal tools that I have gotten to use went away. As I've become more and more familiar with Postgres, which has, most of like writing the queries and all that good stuff, that's all the same. Some of the underlying tables, just like your system tables and stuff, those obviously change, and all of your monitoring tools change. And so it's been kind of a fun experience to learn this type of stuff. But it is a little bit of a, figuring out like, okay, what's going to be the most workable, and especially as an indexer, what matters, what doesn't matter, what's going to make a noticeable difference on my bottom line. So I'm going to share my screen. Let me know when you guys can see that.
Yep, we can see it.
Oh, yeah. Okay, cool. So yeah, so mostly going over like, these are the things that we started to do at Data Nexus, just in terms of identifying which subgraphs we should be allocated to, who's actively querying the network, where can we start seeing query fee revenue, make a difference. And I think I've mentioned this a lot on Windows, huh? Yeah, Windows. I know, right? But yeah, I've mentioned this on other IOH calls, but like, we'll drop 1,000 GRT allocations on pretty much anything that we can see that is producing some query traffic. Because if it's making, even 10 GRT in query fees per day, by the end of the month, you spent, 30 cents opening and closing an allocation in bad times, and, you might make a couple of dollars or whatever. And so, it's profitable to do that, but also you properly support consumers in the protocol and help them as they, grow their applications. So I'll show you just one query that I put together. This one's using the quality of service subgraph, and it's just looking at yesterday's data points. And then I joined a bunch of other local tables just to see, like, are we synced on it? Are we allocated to it? In order to get some basic information. So this is looking at yesterday's data to figure out which subgraphs have the most traffic. Are we allocated to that subgraph? Are we even synced on that subgraph? How many queries are on it? How many other indexers are on it? Like, sometimes we'll scroll through this list and see that there's only one other indexer. It's like, okay, that's probably the upgrade indexer. We can outperform them pretty easily. We should be able to take a lion's share of whatever this amount, right? And so we'll look through this list, and this kind of drives which subgraphs we want to start syncing purely from a query fee mentality. Now, 95% of our total stake is allocated with indexer rewards in mind, but the other 5%, 10%, however much that comes out to be, is allocated with query fees. So this is what kind of starts the process of allocating to some of these. It says query fees, forget me. Hold on, the amount of queries, I assume, is in GRT, not quite. Yes, correct. So this is GRT spent by all consumers, right? You can have, like in Uniswap's case, this 1000 GRT on this one subgraph, that might be Uniswap, that might be other people, no real clue. It just means that there was 1055 GRT spent on queries for this one deployment, and it was split amongst these 10 indexers. Did I get that question right, Josh? Perfect. Okay, cool. So this is one thing that we've started to do, just in terms of, because the easiest way to immediately increase your query traffic is to allocate on subgraphs that have queries. From there we can start looking at tuning our database and tuning things to help be more competitive against these other indexers. And so this is kind of a workshop of like, okay, well, what's that next phase look like for someone that's not really Postgres savvy or not really database savvy? Like what do we do there, right? So one of the first things that I recommend to people is go through this this tutorial, because when you first the out of the box Postgres solution is not optimized, or it's not set up for what we're doing. It has very low default memory parameters, and if you go through this, it'll give you kind of the formula of saying this value should be 15 to 25% of your machine's total RAM, right? And then you can figure out like, okay, well, I've got this much RAM, I'm going to put 20% in there, and just go through the whole list. There's some of them that are just like stupidly low, and I forget which one it is, but there's one, it might be shared buffers, but there's certain things in there where it's like, just by increasing that, you'll immediately start to see a better performance across all subgraphs, because your memory will be more optimal. Once this is complete, and I'd say that on our side, we've kind of deviated a little bit from time to time on some of these values, but with no real noticeable success. And we've kind of come back to this list of just like, okay, we're just going to stick with this. We'll start doing individual tweaks and tunes and all that type of stuff. Perfect. Sorry, I'm also trying to keep up with chat. Okay, so assuming that you are allocated to subgraphs that are producing queries, and you've gone through and you've set up your basic configuration to following this list, but you're still getting poor latency, there's a ton of reasons why that could be, and it's really unfortunate, but this is kind of the role of a DBA to look in here and see, okay, what the heck is happening with all this data? And so let's together we can look through one of these. Now, I cherry picked one of them just because I knew I was going to be doing this. I'm like, well, I want to have at least one good example. And then after this example, we'll go through and we'll look at some active query logs and see if we can find some stuff that we can tune together. So we're looking at this deployment, which I think is Uniswap base deployment. And so I'm going to look. Oh, sorry. And I'm using PG admin to interface with my database. You just create a connection string, and it's really nice for being able to just write queries, store multiple queries, and all that stuff. So if you're working out of the terminal, it's not quite as user friendly. At least I find this to be a little bit nicer. Sorry. Okay, cool. So we're going to be working on our primary shard with subgraph number 1354. And I know that in last week's IOH, we talked a little bit about sharding, or I should say you guys talked a little bit about sharding. I was at the dentist not having fun. But there were some comments made, and we do have a sharded database. I wouldn't say that it's set up the way that I really want it to be. Yeah. For example, like our primary shard, we've got a bunch of deployments on there. And Letter was mentioning like, okay, you should probably just keep metadata and all that type of stuff. And the reason being for that is like every time, let's say we have a base subgraph that we're syncing, we shove that onto our base shard, a query comes in, that query is going to start at primary, and it's going to need to make a connection there before it realizes, okay, time to go to base, let me query there. If you also have a bunch of subgraphs that are stored on your primary, you're just going to be you're going to congest a lot of traffic into one place, and that can then prevent other shards from receiving their pass through quick enough. Oh, it was just a cleaning. It wasn't that bad. I was just saying, like, my hygienist she's nice and all, but she's not as fun as talking about databases. Okay, so we're going to our primary shard, and we're looking for subgraph ID 1354. Here we go. So we can see inside of our table, inside the subgraph, we have all of our tables. And this is just a standard DEX. And you'll pretty quickly learn that most DEXs have some easy improvements that you can add, across the board on DEXs, just because they're all built in a very similar structure. Even their entity names are very similar because a lot of people start with the Uniswap v2 or Uniswap v3 contracts. They fork those, they change them, then they grab their subgraph, they fork that, and they add some of their own changes, but they usually keep the entity names the same, and they usually do the same things. So this is the subgraph that we're looking at. Just to get a general idea, the data that we have in here is we've got basic transactions like burn, mint, swap. Those are the things that users do. You have tokens such as GRT and wrapped ether and all those things. You have pairs instead of pools because this is a Uniswap v2 contract, but pairs and pools are essentially the same thing. And then you have time series data, to see what happened with a pair over a day's time, and then also liquidity position information. So I just happen to know that with Uniswap on base, it had a whole bunch of transactions over the past 4 or 5 months when meme coins on base started going crazy. Vince, I'll change that right after this call. But yeah, so all the meme coins on base started to go crazy. They had a ton of interactions, and we can just see inside of swap. Hopefully this doesn't take too long. We will have some queries that run. Oh yeah. All right, so we've got 13 million swaps that have happened on Uniswap v2, not even v3. This is v2. That's crazy. Okay, cool. So that gives us kind of an idea of how much data we're storing in here. Because keep in mind, with the way that we're storing information, let me just grab something from token.
Hey, Derek, do you mind copy pasting those queries in the chat?
Select all?
Yeah,
Well,
whatever. Anything that you run, basically, just put them in the chat so we can have basically a history of what has been run by you, if that makes any sense.
Yeah. Okay, cool. So
perfect.
Yep. Now, as a reminder, with GraphNode, we're storing full archival information. And so you have this notion between entities and versions. And it's very evident when you get to the token table, the difference between a entity and a version. Entities have the same ID, but a version is a singular record in the database. And so this entity for USDT is going to have some information about it. And that information was true starting from block 100 and, what is that, 10 million? Yeah, 10.7 million, blah, 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 and it goes up until this point. So if you were wanting to go back in time and do some of our time traveling queries, you'd be able to say, hey, where my block is in between this section. So you'll have this instance where you have many entities or many versions for one entity. And this is something that you'll see in just a minute, but it's an easy optimization point. So I grabbed this query and looking at the quality of service subgraph, I was noticing, hey, they are producing query traffic and I'm not getting any of it. And our latency was quite bad. So Vincent set something up for us where we can pull the query logs, and this is something from inside GraphNode, and he set up an API so that I can go through and then scroll and find, okay, here's the GraphQL query, right here, and these are the parameters that they put into that query, and this is something that the website's sending. So now I can see what queries are we receiving, and it also gives us some basic information on how many times are we getting it, what's the complexity of it, what's my average time to resolve this query. Like this one's 7 seconds, that's not good. But then you might have another one where it's like this one's 600 milliseconds, right? Less than a second. That's probably not going to be my problem point. And so then you can start to see where's my problem children, right? Something's only being if you've only got 4 queries for that subgraph, this is probably not one that you'll want to optimize. But some of the higher volume ones, obviously you will. So this is one that I took just because my average response time on it is 31 seconds. Oh yeah, Vincent. Blah, going on behind the scene. Oh, booyah. Vincent included the link in the chat to see how he put together this API. It's something that you can also just plug into your terminal and grab the query logs as well. Or you could build something like this for yourself and grab your own query logs. So what I want to do is I want to see, why is this taking so long? Unfortunately, I can't just copy this GraphQL query into Postgres and execute it here. Because this SQL, not GraphQL. The first thing that I have to do is I have to translate it into SQL. So the way that you can do that is if you go to, you just have to query your own node, and then you want to add a little header. You create a trace query. Vincent will probably have to change this value after this video, because this is going on YouTube. But you add whatever your token is there, and then when you run the query, you can see this one took 37 seconds. I can rerun it for you just so you can see that it does take that long. But before I start running it again, then at the bottom of your query, you'll get this trace. It'll show you the SQL queries that were run in order to provide the results for your GraphQL query. So we can see here, this is one of the queries. Starts here, it goes all the way across, and I'll typically just copy that and then I'll paste it into Postgres, just so you can see what that looks like. I'm just going to put it into a notepad right here, and it's pretty raw. Like when you receive it, it's not particularly happy. And so actually, let me do it inside Postgres because formatted slightly better. So okay, cool. So we're going to select pair as an entity as data. It's going to be from this selection of data. And then we get all these little \T's and all that stuff. So I manually go in here. And there's probably a better way to parse this. So if someone wants
probably
to point me on
throwing
how
it
to
into
do that.
ChatGPT.
Yeah, I mean, I'll sometimes toss it in here and then just do a find and replace. That typically goes quick. But for the sake of the video, I already did it, so I'm not going to do it again. So here's what the query looks like, and the block number that it's specifically querying is this one. So remember when we had that notion of versions and entities? So it's saying, all right, give me all of the pairs where the ID is one of these 362 IDs, and do it specifically for this block number, which is not that complex of a query. But remember, this pair table, because we had 12 million swaps, even if there's only 3,000 pools or 3,000 pairs, it's going to have 12 million records because it creates a new version every time a swap occurs. The total volume for that pair changed, the price changed, right? All these different data points changed, and now you have a new version of the same entity. So that's how you can have, lots of records for something that you should only have a few entities for. How much time would you say you spend optimizing for query performance compared to optimizing allocation selection and sizing? Allocation selection, I spend 0 time on. We've delegated that over to Mike. We've got different dashboards and stuff like that that basically show the same thing that I just pulled up inside of PG Admin. And so Mike will run, he'll open and close our allocations and add new things that we should start syncing. I spend, I'd say probably like 3 hours a week on query optimization. Honestly, I'd love to spend all my time doing this because I really enjoy it. I find it to be a lot of fun because each time it's kind of like a puzzle. But at the same time, I can't spend 40 hours a week trying to improve my data nexus's income by $400, right? If it means the difference of like, okay, we're going to get an extra $5,000 this month, that's a different story than $500. So it's something that we've been kind of toying on with a little bit. So anyway, so looking at this query specifically, if I were to run this inside my database, this is the same query that I just sent to my own graph node, inside of Postman. I grab the trace. This is one of the steps of that query. That bad boy is still running. While it's doing that, I'm going to go back to the trace. So we can see this is one step, and this one's taking up a lot of the time. These two queries are kind of sub-selections. So they're trying to get token information, probably the token symbol, decimals, the address, all that type of stuff. These guys are relatively smaller. So that's why I was like, let's probably start with this one and see what we can do. So going back to Postgres,
why is that thing 7,000 lines of code? Like what else is inside that result? There.
Yep. So this is the response to the query.
Oh, that's the actual response to the query. Okay, yeah, got it.
Yep. And so it's got your, all the pair data that they're selecting.
Holy shit. Okay.
Yep. Okay, good. So running this query took 21 seconds on, just directly against my database, which is very bad. So this is the thing that I want to optimize. You can pull an execution plan, which will look like this. It might take another 20 seconds. Inside the database, when you run a query, Postgres is going to try to figure out like, all right, what's the smartest way for me to execute this query? And it's going to look at things like what indexes exist on the table, what statistics do I know about this table, what do I think is going to be the smartest way to perform this query? And a lot of the times it does a very good job, but there's times where it does a terrible job just because it's missing some information, or so many new records have been inserted and it hasn't reanalyzed what's inside the table, etc. Typically, if your table's only like 1,000 records or 1,000,000 records, it's not going to be that bad. But once you start getting into the tens of millions, hundreds of millions, or greater than that, that's where you're going to start to see major scaling issues, and you're going to need to make sure that you've got proper indexing, proper statistics in place in order to tell your query planner like, hey, you could spend a lot of time doing an inefficient query, or if you use these tools, you can start to do some smart things. And so here it's showing that it's trying to utilize this specific index, which exists. What is it? Attribute 2.0 pair ID. So it's trying to use this index, and it's saying, yeah, it's going to take a while, right?
So in order to trigger that, you have to run explain analyze. And how did you choose the like what does buffers do? And the other
it just gives you
settings?
some more. Yeah, it gives you some more information. I'll show you that in just 1 second. And you can literally add it above or before any select statement, and it will give you the execution plan. So now you're seeing, okay, how does Postgres think that I should execute this thing? We have a membership with PG Mustard, not that one, PG Mustard, and you can paste that same execution plan. I think they give you like 5 for free or like that. After you've read a few execution plans, it starts to make more and more sense. But for the sake of this IOH, this is a much easier way to kind of read this thing. And we can see that when I first ran this, it took about 100 seconds. When we just ran it, it was down to 20 seconds. That was definitely an improvement. But this was like a few days ago, so my database was doing other things at the time. And we can see that most of these steps in the execution plan are pretty simple. It's this one that is our problem. So it wants to scan this whole index, and that's taking a while, right? And the big issue that we'll be able to see is it thinks that it needs 46 gigabytes worth of memory to be able to read through that entire index, which is, that's not good. In actuality, it needs far less, because it's planning for a lot more rows than it's actually needs to have. And then let me pull up this message from Vincent. So I saw this and I was immediately like, oh, this one is not so happy. So I asked Vincent, hey, can you run that graph node command? And Vincent, if you could toss whatever that command is to get the versions and entities. There's one tip that I super recommend. Oh, I gotta keep scrolling. Okay, cool. Here we go. This is inside our team chat. Sorry, I can't see the chat right now. Vincent should be dropping in what that command is. And it gives us a table to be able to see how many entities does something have versus how many versions does it have. And you can see bundle, which this entity just stores the price of Ether, and that's used as a control to be able to figure out the price of other things. And it literally is just one entity, and it just has a new version every time the price of anything changes. You have things like pair, which is the one that we're working with, where they have 1,000 different pairs. They've got 12 million different versions. Swaps, you have 13 million swaps, which is each swap is its own entity, right? And the data of that swap never changes. So in this one, you should have an exact parity between entities and versions, which would give you 100% here. And if this is ever true, the subgraph developer should have put an immutable entity here, because the data literally never changes, right? Transaction, data never changes. User, data never changes. Whether or not they did that is kind of outside of our control as indexers, but it's something that we can complain about. But in our case, we're dealing with pair, which we can see there's very few entities compared to the number of versions. In this case, and this is the understanding that I have from Lutter and from some of the people that I've kind of talked to in passing, is we have the ability to set this flag for account like. And what that's going to do is it's especially useful in scenarios where you have very low number of entities and very high number of versions. So inside here, we've got 1,100 entities and a whole bunch of versions. And so I was like, great, let's apply account like. Now, what that should do to your query, Vincent, I'm going to ask you to reset account like on pair inside this table. What that should do to your query, and I haven't been able to fully confirm this, but this is what was told to me. It just doesn't show in my trace, so I can't see it when it happens. But it should literally change your query or the way that it gets executed slightly. So rather than using this operator, which this operator is called a contains operator, right? So you got greater than, less than. If we look back at that, hold on, let me just pull it up. If we look back at that table, cool. Okay, so we've got this block range, and this is what's known as a multi-dimensional field. So this has one value, this has one value, this has one value. This has two values in it, right? It's an array. You've got value 1 and value 2. The contains operator just says, hey, where this number is between that first and second field. Or, I want to make sure that the record that I'm selecting is true for this specific block. And we use this to obtain that. Which this can be very performant when you have a low number of records, but when you start having lots of records, it gets to be kind of heavy. And the index on that column gets to be kind of heavy. If you change it to these two things where you say, hey, where the lower value is less than that same number, and the upper value, right? To break this down, what coalesce does is it's going to select the first non-null value. So if this has a value, go ahead and select that. Otherwise, we're going to use this number, which is a magic number. It's the largest value that a 32-byte integer can have. And so you couldn't store that number inside of this field. It just won't work. So it's going to say, all right, so where the lower block range value is less than this amount, because I want to select whatever's in the middle, and the upper block range value is greater than or equal to this amount. So I want to be in the middle. I want this number to be higher. I want this number to be lower. And remember, when we first ran that query, it took about 20 seconds. If we run it again using these, it now runs in 700 milliseconds, which is happy days for me. So 1 second, 1.6 seconds. That's not like stellar, but it's not terrible. Usually you have your first run, which is the slow one, and then after things start to get stored inside of cache, then cache will help speed things up. You have your index that's already in cache, so you don't need to repull it in there and all that type. So there you go. So when I ran this, I was like, oh, okay, cool. First thing that we should do on this table is apply that account like flag. And I'm just verifying. Sorry, I have not been reading the chat. Blah, blah, blah. Yeah, Graphman stats. Okay, cool. And then Vincent, if you could also type into the chat the command for actually setting the account like flag. And we can just use this one, the SUD 1354 pair, as an example. Obviously, don't go try to run this against yours because your Uniswap v3 base is not going to be 1354 on your local machine. But yeah, so you'll have to look through, and I started putting together queries just to figure out, like, okay, can I identify ahead of time the scenarios where we've got really low number of entities and really high number of versions, just so that we can kind of proactively apply this flag. So far we've got some mixed performance with that, so I'm kind of tinkering with that guy. But this is something where you need like just almost no skills. You just have to figure out, like, oh, this is a bulky table and it has very few number of different records. It just has a bunch of versions. And so then you can go and apply this account like flag, and that should improve your query performance. So that's one kind of major improvement that you can do. Um, well, I mean, once you can run the query that Vincent posts, sorry, this is in response to Josh's comment. Once you run that Graphman stats and you're like, oh, hey, look, that number's way bigger than this number. And then you run the account like, then you're good to go, right?
How do you revert if you accidentally set something on account like?
I think Vincent, is it the same command to undo it?
And before you have to drop the entire database?
Yeah, don't drop database.
Don't
I'll
back
give
up the primary.
Okay, perfect. Vincent included
Okay.
the unset account like flag. So you can kind of test it out. You add it in there, check and see, okay, did my queries improve? Nope, they degraded, right? And sometimes it takes a few minutes for things to kind of pick up and the queries coming through the gateway and all that type of stuff. So give it like 4 or 5 minutes. And
So
then
literally without any kind of index set prior to this, you just set it to account like and it magically works faster?
yeah, and here's why. So when you add that new query, right, this was our original execution plan, right? And it's trying to shove just a ton of information to read through to be able to give us our 200 records or 300 records, whatever it is, right? And when I first ran this a week ago, back when we had some other things happening, it took 100 seconds. Afterwards, you rerun that same query and you have a new execution plan. And it's like, oh, rather than using this kind of nasty one and having to pull the whole thing into RAM and read through all that, which I'm going to need multiple gigabytes of data to be able to do that. Instead of doing that, I'm just going to pull in these little two baby guys, right? And you can see this, ran in a second. And so by literally changing that one flag in this instance, that was the right solution there. Did that answer that question?
Yep.
Bueno.
I was asking because I already did this without even knowing what it's doing, and yeah,
right,
it worked out on my end.
Yeah, I mean, there's been people that have kind of like mentioned, okay, well, here's what that should do, and so I just wanted to show you that this is the same execution plan that we've added in this lower block range and the upper block range. It then says, okay, cool. We're gonna, rather than using that earlier index that we saw, we're gonna use these two guys. It's gonna give us a much more performing, which that's happy days, right? Going back to this guy, if we were to rerun this, and I'm hoping that everything's kind of refreshed at this point, rather than taking 37 seconds, doesn't look like it's gone through yet. Sometimes it takes a minute for Postgres to wake up. Yeah, where's the Homer? Oh, okay, good. So there you go. So that was the first thing that I did with this query. Then the next thing that I wanted to do, because like a 1 second query still isn't like what I would consider to be ideal. And I'm not at the point yet where I'm like, oh, okay, we've got 13 million records. Maybe I just prune it and delete everything and say, screw you, time travelers. I'm not at that point yet. So the next thing that I want to do is I want to look at, these indexes are pretty good. I'm also just going to add some statistics, right? And I believe there's a command to do that from inside GraphNode. Vincent, if you recall what that command is, if you could pop that into the chat, it'd be awesome. I prefer creating statistics just inside of the database directly because that's where I'm better. And so then I started to create some statistics. And what statistics will do is it gives the query planner a better idea or a better gauge to see, hey, this information has roughly this many different types of values. And like it makes a whole histogram of information in there, and it does data sampling. So it's going to grab a certain percentage of the records and see, okay, how many times do the values start with the letter Q and the letter P and the letter T, and from there it can start to be a little bit more intelligent of like, let's say I were to try to filter my query by a word that starts with the letter Z, and it says, okay, that is that does not have a lot of values inside of it. I can probably jump straight towards the end of a certain index, and it just gives it more information. So we're being more helpful to Postgres if we have statistics. Downside of creating statistics is that it does use up more memory. So you don't want to just go statistics heavy and create it on everything. You want to create it on the things that actually matter. And ideally, you can do it on columns that have what we call cardinality, where if one thing is increasing, the other thing is increasing in a similar way. Like a block number and a timestamp, those two increase together. Oh, Vincent, I think there's a command from inside graph node to be able to set statistics for a table. Ellipra is
How
not
do
in
I
here.
how do I unset the statistics after I turn it on?
It's a great question. From inside graph node, I don't know. From inside SQL, you just write drop statistics.
Ooh, that's scary.
Yep, the word drop is always a little freaky.
Yeah.
I'm gonna post this in here just so you can see, or have a sample. This creates.
Just imagine you forget to type statistics and you just drop the entire part with like.
I mean,
yeah.
I mean, executing this in the terminal, you want to be really careful about what you're punching in there. Oh, perfect. Okay. Quick shout out to the POOP. Secret phrase is able. I see what you did there. Okay, cool. So now we've got statistics. I'm hoping that things will have refreshed over here. So that one took 15 seconds. That's still not super happy. Okay, and that one took 1.3 seconds, which is a lot better. Looking at some of the other indexers on this specific query, okay, 400 milliseconds, I'll take that all day long. Some of the other indexers, 0.624, that looks good. A lot of the other indexers, and before I optimized this query, my average latency was like 6,000 milliseconds. 6,000 milliseconds or 6 seconds. If I can start to improve these queries, then I can get myself down to closer to these numbers. The downside to this, and this is the part that really sucks, is that, this one, is that that's just this one query. And we have other queries that we can optimize as well. And the ones with not a lot of traffic, I'm not going to spend time doing that. But if I'm looking through my query logs and I find something where it's like, oh, hey, this represents 90% of the traffic and it's slow, then to me that's like a prime one to look into and figure out like, okay, what can I do in order to improve this? I'm being a little bit conscious of time because I know that we've got 7 minutes. I would say kind of the next step that I would like to get into is how to start creating custom indexes. I don't know if we want to plan on saving that for a different time and we can do questions now, or if we want to just jump into it and
let's just jump into that so people get to test it out throughout the next week, and maybe we can have the next IOH for questions that rised up throughout our this week testing stuff, if that makes any sense.
Yeah, sounds good to me. Okay, cool. So and I don't have this video. There's it's like a 30-minute video where someone goes through what is a B-tree index. And if you don't have like a conceptual grasp of what an index is, I super recommend watching that because it'll make, it makes a lot of sense as to why indexes speed up queries. I'll try to do a really poor example. If you have a table, and we'll just have an ID, car, and model, right? Your IDs are oftentimes, well, not really for us, but outside of the graph. You oftentimes just have an incrementing integer, which is really nice because they're always unique and they're predictable. Let's change this to make. We'll say Toyota. Paste this around. Honda. And then Ford. Why not? Oh, I spelled. Whatever. We can do it without this one. Okay, good. So when you're trying to select from this table, like visually, here, and I can make this bigger. If I were to tell you with your human eyes, find me record with the ID 6. Oh yeah, that Toyota Civic, baby. No, it's not Honda Civic. If I were to ask you, hey, find record number 6, super easy to do, right? You know that this is sorted in a ascending manner, and so you just jump to the middle and you're like, boom, 6 is right there. And the database does something very similar. It knows that this is, the records are sorted by this field, and so if you're using an ID, it knows how to grab that nice and quick. But if you were to instead say, hey, I want you to count the number of times that Honda appears in this, then you have to go through and you say, okay, 1, 2, 3, 4 times. But you literally have to go through every record in order to figure out how many times does Honda appear. What an index does is it's going to take this field, and we're going to go to data sort, and it's going to make it look like this. So now you can say, okay, how many times does Honda appear? And now your eyes can visually jump to the H, because H is after F and it's before T. And then you say, great, count these, and as soon as it's no longer Honda, you know that Honda stopped, and you can count things quicker. So rather than have to do what we call a table scan, where it's scanning through every record on the table, right? With 12 records, it's not so bad, but once you have 1 million records, 10 million, 100 million, it starts to get pretty cumbersome. But if you can instead utilize this, where you're like, oh, I only need to scan through this and just kind of jump through a couple halfway points in order to get here, then you're going to be a lot happier. This gets sorted in what's called a B tree, which gets to look like a pyramid. So you have your halfway point where you have Honda, and then it's going to branch down into 2 little trees. And the halfway point here is Toyota. And so it starts to make what looks to be like a Christmas tree. Honda, and then you have Honda, Ford. And so it's going to start at the beginning of this tree and say, okay, is the thing that I'm looking for, is it before this word? Is it after this word? Is it this word? Oh, it is this word. Okay, perfect. So let me go and grab, is it after the word Ford? It sure is, which should be these 2. We'll include this record, and then let me go after this. Is it before Toyota? It sure is. Let me grab this one. Yeah, there you go. Yeah, I'll find the specific video, because there's a really good one that goes over like, okay, how does that actually get stored inside the database, so you have like an idea of physically what does this mean and why is it more performant, right? So, and that's just an important thing to be able to use for this next step. So now what we want to know is like, okay, how do we change, or how do we look at a query and know what should be indexed? Anything that is included in the where clause or inside the ordering is something that is probably smart to have indexed. Now, by default, GraphNode over-indexes stuff because it has no clue what queries are about to be run or how much data is being stored in here. It has no clue. And so it takes the over-indexing mentality. Let me create one index for every column that exists, and a couple extra ones on the side of the IDs to try to make those a little bit more performant. But if we look at some of these queries, oh, that's not my query logs. This will be my query logs. So looking at this query, we can say these guys are trying to query something that they're calling pool buckets. And they want to know where the ID is equal to this specific ID for this block. Okay, that's pretty normal. And then they want to get pool hourly information, so that the hourly amounts of what's happening with this pool. And they want a certain amount of information. So the first 100 records, right? We're not going to do anything with indexes on that. And they want to order it by this hour start Unix, right? So if we look back in our database at that pair hour data, it should have a column for hour start Unix, which is the beginning, the first timestamp of that hour. So, okay, cool. We know that they're ordering it by that. Now this one column already has an index by default. And that should be hour start Unix, pair hour data, hour start Unix, right there. So the index already exists. Now, what would happen if you instead had multiple where clauses, right? If you said where the hour start Unix is greater than X and the total supply is greater than Y. Well, now you have two items that are filtering the results of this table. So in that circumstance, you could create a custom index where it says, great, I want to index both the hour start Unix and the total supply. And that lets me filter this Excel sheet, lets me filter this even further. Because if we were to pretend like we had models inside here, we have all of our Toyota Civics, all of our Honda F-150s, and all of our Ford Eclipses. Right, being able to sort it first by the make and then by the made-up model, gives you better sorting sorting features, right? So you can say, okay, great. First go to Ford and then find the Eclipse. Using Excel with keyboard only, yeah, right. It's just faster that way. And so yeah, so those are the things that you want to be looking for. I typically try to in the order that you're setting inside these indexes is important. Ideally, you want to take a parent field before you take what we call a child field, just because this is going to help sort things faster. We don't totally have enough time to go into the what is a parent-child relationship and how does that make sense when you're writing queries and all that type of stuff. But we can say that for the next one, just for index tips or whatever you want. But for the most part, when you're looking at your query logs, you'll want to see some of these where clauses. Try to find one. That's a really annoying one. Okay, where the pair address is equal to those bytes, fine. That's single field, and and they do order it. Okay, so here's a good example. So they're querying pair day data. They want specifically where the pair address is equal to some ID, and then they want to order those results by the date descending. So give me the most recent days for this specific pair. Maybe they want to see what happened with this pair in the last 7 days. So if you were to create an index where it was on the ID or the pair address, and then it also had date inside of there, then that would be a really performant index. Now, the more fields you add, the more storage it's going to contain, and the harder it's going to be to pull it into RAM. But if this query is dominating the overall query traffic, it might be worth it just sitting in RAM and being able to serve that query really performantly. So it really kind of depends on scenarios. And like there's a saying with DBAs where you'll ask them a question and they say, well, that depends, because everything is very situational, and there isn't like a silver bullet. Oh, this resolves all things, because the data inside tables is very different. The number of tables inside of a subgraph is very different. The number of columns inside of it is very different. And so each one, has its own kind of unique circumstance. You need to be able to see it, understand roughly what are they trying to accomplish, how are they trying to accomplish that, and then from there you can start to get an idea of like, okay, well, what are things that I can tweak to help them accomplish that in a better fashion. DBA certified trackball? No way. I actually use a on my laptop. I have one of those the little finger things, the little rubber thing between my V and my B keys, and I just track along with that one. No, I don't actually. I've got a mouse. Yeah, yeah, exactly. I think that. Okay, cool. So I think this is a good spot for me to kind of leave it for now. I have been trying to find that, Josh. There it is. Wouldn't you know? Okay, cool. So with that, I guess let's stop here for now. If there's any immediate questions, happy to take a stab at those. And if we want to do a little bit more on future IOH, I'm also happy to do that.
Amazing. Do folks have any immediate questions that maybe we can quick fire? If not, then we can always. We're getting a lot of thanks in the chat. This is great. I think to be fair, Derek, I think you did a fantastic job of answering questions as they came up. So I think we should be good. Yeah, very knowledgeable. Derek, and an amazing team you have there. Let's do this. Let's massive round of yeah, let's so we have another one of these sessions for next week. So as been mentioned, there's a lot of information that we've been discussing here. Hopefully people play around with some of this and then come up with questions next week. You'll be around next week, right, Derek?
Yep. Yeah, Tuesday
Okay.
I'll be here.
Okay, awesome. In that case, then you can join the session, and if people have follow-up questions, then we can get them answered there.
Hey,
thank
Derek,
you so much.
one last
Sorry, go ahead.
question before we leave. With this account feature, when you said it, how do you know if you already said it or not on something? Because I don't remember if Grafman Stats actually shows that. I don't think it does.
It shows this little A right next to it, and that's your indication that account is set.
Okay, got it. Thank you.
So I'll share a screenshot of what that looks like. Like, oh, that thing.
Oh, that thing. Okay. Thank you.
Perfect.
Amazing. Thank you so much, Derek. This was incredibly insightful, as you can tell. Everybody loved this. So yeah, very much looking forward to continue the conversation on this topic. We're going to have more of these kinds of things coming up. So yeah, thanks, Derek, and thank you all for attending today's session. Amazing.
Absolutely. Looking forward to doing more stuff like this.
Amazing. Me too. All right, take care, everyone. See you next week. Bye-bye.